Hello, and welcome back. So this is continuing on in a series on my tips and tricks that I have kind of for coding, and just general advice I have. Most of these things are very, very big, deep topics that we can do full series on. So uh, some of them I will be expanding and doing either a series or a course on, but you can just think of this as just a general overview, some of the things that I think about as I'm coding out something. And this is honestly just more examples of actual code that I might put out, and or ideally I would put out when I'm coding up a new project. So today we're going to be talking about limiting your types. So what's often the case that I see when someone's coding is they think about very general use cases um, when they're coding out something, and and that usually is people's first approach to making their stuff super extensible. And if you kind of want to hear my example of extensible, please check out my last video, which is extensible classes. But usually people they try to keep their data types super open so that other things can come in and use them really easily, or people are more encouraged to use their stuff. And it just, like I said, when they're designing, they're thinking about very general use cases for their stuff. But the problem is that the very general use cases are probably rarely how your code is being used 80% of the time. And my argument is that you should code for how your code will be expected to be used 80% of the time. And someone should be able to look at any piece of your code and understand exactly how that code should be used. So we're kind of going to just walk through an example today of how you can, once again, I'm a big fan of kind of giving hints at exactly how this piece of code is supposed to be used. And then if someone else wants to adapt your code in the future, your code should just be easy to adapt, but it shouldn't be something that is easily adapted. It shouldn't be something that 100 people that have never used your library before, but they come to it and they go like, oh, this is exactly the data type that I needed to use. That shouldn't be the case. And so I think a very common data type that people will code out is a user object. And if you watched the last video on extensible classes, we used a user object in that, but this user object might not actually be the exact same as that one. We'll just kind of grow naturally from it. So, and actually, I think one of the first things I want to give this user. So, like I say, a lot of people will code up user objects, but not all user objects are going to be the exact same. So, the Twitter user object that they're storing in the Twitter database might not be the exact same as the Facebook user object. And so you should get that out of your head, that I'm going to build the perfect user object that can be used on any social media website, and then it can also be used on a gaming app or anything like that. You're just not going to build a perfect user. So just build it exactly for the use case that we are trying to code for. So in this example, when I'm thinking about what I'm trying to build this user for, I'm maybe I'm building out kind of an event planning website, or I'm building out kind of an invitation list towards people. So if someone's about to have a wedding, I want to be able to, maybe I have some API that I'm calling that if I can supply it the address and the message and like pictures, then this thing is going to print out and send off emails to all those people. But I have to be the person that supplies it some user object or something like that. So, or I need to at least be able to store all that data in my database. So for me, like I say, and really, I would almost call it maybe an attendee. So, attendee. I'll rename this. And at this point, if you've watched my struct video, you understand why I'm starting out as a struct for storing this data. So for an attendee, I might have, and this is, I'm just going to show you kind of the common way that I see people code things out. So for the attendee, I would have a string that's like their name, and then I have a string that's their address. And do I, maybe I'll also have, maybe is going. Okay. And maybe that's all I need for this app is it's just the name to put on the card, the address, and then something else is going to supply, the location of it and all that stuff. So now this is like, if I kind of pose this problem to any coder, I would say that probably 80% of them would code it exactly like this. But this is 100% wrong. And kind of just when you look at it, maybe start to just kind of think about what are some of the things that this thing hasn't given me a hint about. Or think about some of the problems I'm going to face as I'm coding up this solution to of whatever I'm about to do. So I'm about to send off the address to some UPS API that's going to be able to print out labels and give me all the labels that I'm gonna need to send off to this thing. And I'm storing this thing in a database and all this stuff. And so maybe I'm doing all these kind of validations on it. Okay, so the first thing is, I think the first thing that sticks out to me is probably the biggest challenge is the address. So the address is a very complex space, and it has a lot of, the first thing that pops into mind is format. There are lots of rules for different addresses across the entire world, and a string is an awful data type to try to capture all of those nuances inside of. Now, sure, there are string to address translators that exist, and they have different levels of ability. I think they've gotten pretty good, but at this point, we've had to actually involve ML in the pursuit of finding the perfect string to address converter. So this is actually why there's very few websites that just let you type in a string for your entire address. Instead, all these websites require you to give the street name 1, and then the street name 2, and then the zip code, and then the city, and then the state that you're in. They expect you to go through all the hard work for them, because it's actually a very hard problem to decipher the address from a string into the proper format for your UPS. And so that's the problem. That's the exact same problem you're going to face. UPS is not going to accept that string of an address for the address. It's just not. So you're going to have to either build your own parser, which, like I say, building a parser from an address string to an actual address is a very hard problem that is still being solved right now. Why? Because most people have not switched to allowing you to just give a string for your address when you're checking out. Most people have not done that. So you're going to be stuck building a parser to do that, or you could just say, I'm going to store the address properly into a format. So in our case, we are going to just assume that all these addresses are in the US because I'm based in the US. And so that's just how it's going to work for this example. So like I said, the first thing, and this is, like I said, this is called limiting your type. So a string is a way too broad of a data type. A string works for a lot of stuff. So I see this example, and don't feel bad if you fall into this camp, but I see people using a string for way too much. It's almost like, abusive at this point, all the things that people use strings for. So what we're going to do here is we're just going to limit that type. And maybe this will start to kind of produce a little red flag in your head that says, hey, don't use string for everything, for every single thing. Maybe, and really start to question, is string the best thing to use here? So, so for the address, like I said, we have, once again, I'm just going into the default mode of, okay, what really am I going to put in here? So maybe street address 1, street address 2. Then and like I say, I'm being really loose here. I'm saying, okay, I'm going to store the city as a string. I'm going to store the state as a string, and I'm going to store the zip code as an int. Now, right away, someone might ask, well, why not store the zip code as a string? Well, once again, you're being way too loose with the zip code, because the zip code can store, or a string can just store just about anything, right? And so technically, yes, a zip code could be stored as a string, fine enough, and it's eventually going to be interpreted to a string, probably, for if you were punching into an API or something like that. Maybe it wouldn't really distinguish the difference between a string and an int, but it is storing it as an int solves so many problems for you. What if someone punches in something that is not a number for the zip code? Well, it's not going to pass any kind of validation that we might do. It's once you try to convert the value that they give you into a zip code int, you've already got the program of C# working in your favor, because something's going to crash, and you can report that crash back to the UI and say, hey, I wasn't able to convert your zip code. So, and we might not get to code that up right now. Validation, once again, is another big, huge topic, but you can, if you've coded up anything, you can maybe see the difficulty in converting a string to an int. And I would give that to you as a problem. Your compiler isn't going to allow you to do it, so you're going to need to build something, maybe runtime, that converts, or we might be able to build an actual unit test around it. But yeah, there's going to be difficulty. This is going to crash if it can't convert a string into an int. And that's what we want. Because that's exactly the type. So now tearing apart this address. So I'm going to go up here. I'm going to change that type to address. And so we're definitely doing a lot better than we were before. But now let's start to kind of ask some things. Let's ask for street address 1. For the field of possibilities, is a string the best option here? So with a street address, it could have all kinds of stuff next to it. It could be 1, 2, 3, alphabet, lane. It could be something like that. It could be 101, 160, I don't know, 3rd Avenue, Southwest Street. So it could be all these different kinds of formats, and it could be pretty complex to figure out that mapping. And so I would say, okay, yeah, fine, right? A string for this kind of example is totally okay for me, right? I'm not too complaining, because I don't really understand all the different types of fields and I would be looking at an address code book. It would be really complex, and I can type that into the UPS store and it can figure that out pretty good. So mission accomplished here. String is an okay data type to use here. I would not go further and start making data types to store like the building number next to the street name, or building number on street name. I wouldn't get into all of that kind of stuff. So, and then something like this might be like an apartment number 99, or it might be unit 101, or it could be building 2 unit 44, right? So it could be a wide range of things too. So once again, okay, I'm good with this. And sometimes the building is even up here, and sometimes even the street address is on line 1, right? They like to join everything together. So, that's, here we go. Like, okay, street address, this is totally fine for me. I'm okay with it being a string, because there's just a wide array of things that this thing could be, and we don't want we don't want to capture all that logic within our code. So we're going to say for our data type, this is actually okay. And so we make a concession. It's not 100% accurate, but it's pretty good, and it works in 80% to really 95% of cases. I'm going to be fine. I'm not going to need to distinguish the number out of here, right? So I'm totally fine. For the city, now this is where we get actually a little bit trickier. So here you have to make the decision: do I want to store every single city in the United States in my database? And then, I could do something like this. I could say I've made a city data type, and if that city data type is not one of a million cities that I've stored in my program, it's not allowed to be put into the program. But the reality is that that's pretty hard to code out, pretty hard to find that list. Now you're storing that corpus of cities. Now you've got to keep that thing up to date. It's a lot of responsibilities. And so we say, no, once again, I'm okay with the likelihood of, I'm okay with this. I'm okay with it being just a string, because I'm not going to go through all the work of writing something that would compare it against this list of millions of cities. I'm not going to do all that work. I'm actually going to move on here. And that's a concession that you make, right? You write it down, you note it in your design doc, and you move on, right? And then now we come here to string states. And this is where you can have a lot of contention with people. So, and this is one where this, I could see a lot of contention in a room between devs on whether or not this should be stored as a string or should be an explicit data type like state. So what I've said before was that this is indeed going to be a United States address. So in my opinion, because on your UI, you probably are going to code out, if the person on your UI has coded out a list of states in the dropdown on it, then I would say that you would want to keep that list of states inside of this database. And it should be something, that list of states should be accessed from this section of the code. So it shouldn't be something that lives independently. It should not be a list that's hard coded in the HTML. That list should be a server call to this piece of the database. And this piece of the database, what that would mean is you would make some enum here called state, and then you would just list out every single state. So, like Arizona, Alaska, and you just go on. It goes on and on and on and on and on. So, that would be how you would do it here. This enum would be iterated through and exported out to the UI, and the way to do that is you can get the last value. So what I always say is to always have a last value here and to always have a first value here, though the first value is always going to be 0, so it's pretty easy to keep track of. But you do a last one here, and then what you'll do is you'll do state dot last, and you'll convert that to a number, and that'll be a number, and then you make a for loop that iterates from 0 up to that number, and you'll cast each of those numbers into a state. And then that casting, once you do a cast from like state 0, state 0 is going to give you first, but if you do state 1, that's going to give you Arizona as a string, and then you pin that to a list of strings and then pop that out. So that's how you would export this enum of states. So I would, in our case, we have said that these are all US addresses, so this is the ideal way that I would code this out. Like I said, you don't really need to have a first index there. And in our case, I'm going to actually remove it because that way last will equal 50, and that can kind of be a sanity check for us that last is always equal to 50. I was like, yeah, we are 50 states for now. But yeah, this is 2022. So it's 50 states for now. We'll see about Puerto Rico. So anyway, now moving on into zip code. Now zip code is another very interesting conundrum. So we already had the discussion that string is too wide for a zip code, but is int too wide for a zip code? If we look at what a zip code might be, it could be, it's 5 digits. It's always 5 digits, and maybe it has some other, another 4-letter number or a 4-digit number attached to it. And so that there is also an opportunity to kind of ask yourself, well, is that information that I would like to capture? I will say that, this is really a discussion between you and your UI designer, because if your UI designer makes it where they can type in, if they type in that negative sign, that hyphen, then that means that was taken in as a string. And that means that you're going to have to splice that string off in your request call, and to store the first part as a number. And so if in that case, if your UI is taking this data in, then your database needs to be able to take in all of that data. So then that way so if your UI can take this in as a value, then an int is not sufficient, but a string is too wide, in which case I would tell you make a zip code struct. Ugh. And I mean, I'm making it stupid simple, but first part, second part. And then and this is actually one of the first examples too of this is an acceptable function to code inside of a zip code. But if you do a public string, and this would maybe be considered like overloading the toString method, would be an option here. I'm not gonna, but just assume that's kind of what I'm doing. Let's just call it output. Then I would say return toString plus, what's the prettiest way to do this? Maybe first part dash second part. Okay. Cool. And so this is, once again, I would have overloaded the toString method, but like I said, I don't want to jump into all of that. But this would return it in this format here, so it's nice and easily readable. Even your UI now can access this method. So cool. So this is an example. Like I say, I would only go down this route if my UI were allowed the user to type it in just like this, right? Because then I wouldn't, because like I said, a string would have been way too wide to store just all this stuff, but an int is too restrictive because it doesn't allow the hyphen. And so I'm just making my own data type that separates them out for me. I don't need to store the hyphen because I always know the hyphen will be there. So, but I will give it to the string, and that the rest is history. So there you go. We just walked through what it would be like to limit the types in your struct. Like I said, once again, we started out with a very simple data type, right? We just had a struct that was an attendee. It took a name, took an address, bool is going, and most people would have been off and going. It would have been done with this code and moving on to the next thing. But we said, no, a string is way too wide. We can't necessarily do any kind of validation on this address because it was passed into us like this. And so what we're going to do is we're going to have a stronger contract on the address. And for people, that aren't more used to the word contract just says that these are the restrictions that I place on any data that's passed to me. So if I just say that I accept any string as the name, that means that I should be ready to accept gobbledygook as the name, right? Yeah, I should have no complaints with it. No part of my code should crash if it receives this as an input. So I argue that name should have some restrictions. And I'll leave that as an exercise to the watcher, to the viewer, to think about some ways that you might restrict this name class down to be something that would actually block out something like this and would fail validation when it encounters something like this. But like I say, so we said that the name is I mean, I'll kind of give you a hint. The name on a card needs to have a first and a last name for an address. So it needs to have a first and a last name. It might have multiple people on that two line. But just think about the label of an address, and just think about how a string might not give you the accurate label on that address, and it might fail some validation somewhere. And so after that, we said, well, the address also has a lot of restrictions. So the contract was way too loose with just a string, because that's going to fail a lot of validation if I just allow any type of string to be passed into the address. And so we went through the process of making a much stricter contract, and we kind of went through the concessions that we're making with each decision until it got to the point to where, okay, I can actually get a little stricter as we went down that list and make sure that everything is in exactly the right format. So I controlled the things I could, and then I was a little more loose with some of the things that were either way too hard to code solutions for, or things that on average are not usually issues with people typing into forms. And then this last one, looking at this Boolean argument, this is an example of just this is the most specific of a contract you can get. It's a Boolean, a yes or a no. There's no other option that a Boolean can be. It is 0 and 1, yes or no, on or off. So this is the ideal world to live in. If you could only code in Booleans, it would be pretty amazing, because you would always know exactly what you cared about. There would never be any kind of confusion, there would never be failures to interpret the input given on a form, because the Boolean, it either is or it isn't. So this person is going. We don't ever have the confusion. If Boolean is set to true for the value is going, we're not unsure if they're going or not. Like we're very sure. We're 100% sure that they are going. So because they marked it as true. Now obviously there's you could imagine if instead of is going, you gave it like probability of going, and now that's this decimal. It's this float, and now we've lost a whole bunch of all the generalization that we could have done on is going is all lost, or it becomes kind of a proportion or a probability. So now it's like the probability of this person going is 80%, and it's like you've gathered that from all this other data, but it becomes a pretty wide contract at that point, and it's like, how can I can't really book tables, or I might not want to book tables, right? Depends on my risk tolerance. I might not want to book tables on the probability of this person going, but I'm able to book tables with the value of is going, right? So this is the most useful thing to me, whereas probability of going might not be that valuable to me. So and oftentimes this is all just an exercise in making your life easy. Oftentimes with these kinds of contracts, you don't get to change them later ever again. So if you've built this address, and it can be hard to think like this, once you've built this address label and you've sent this off to your front-end web dev to code it out, or maybe you are the front-end web dev, once you've coded it out and put this out to the internet and people have used this form, you can't just go and change things in that form all the time. Imagine that the first 50 people to your wedding have already maybe they filled out this contract that was just a string for the address. And so they filled out a form of the attendee that was just a string to address. And then you realize later, oh, well, all these 50 people, they filled it out wrong. What they really should have been filling out was this, conforming their address to this. Well, you can't. Now you have to go back and repoll those 50 people, which could be really expensive for you. because now you might have to call 50 people and ask, was this the right thing to actually fill out? What did you actually mean to fill your thing out this way? And that can be super expensive and cost you a lot of time. So it is important to think about your contract a lot, right? Even another, and this is even the worst thing, is if you leave out a value in your contract. So what if I'm going to put this value here, phone number. What if you actually needed their phone number the entire time, and you coded this up, you built it, you built your front end UI, you sent it off to people, and then you forgot to ask them for the phone number, but UPS requires their phone number, a phone number for each individual address it sends to. It all of a sudden required this phone number for you to give. So this is an example of you completely forgot to add this to the contract, and now 200 people have already RSVP'd and filled out this form. And so now either you have to make them all go through the form once again, or you need to call up all those, or you need to fill in all these by hand now. Now you're scraping through your phone list, filling all this information in. So it really shows you the importance of taking time to think through your contract, run it through a few example scenarios, maybe even run it through your first 5 people that might use this app. And then once you've solidified that contract and it's well designed for the problem that you're trying to solve, then you go ahead and send that out and you publish it. So, all right, that's going to be the end there. A few things that I leave you with to think about is if there are any restrictions that you would leave to the name. Like, is this a valid input for a name, right? So how much you restrict the name down. And then, and restricting the name also could mean restricting the name to alphanumeric characters. So there are ways to restrict like that. Same here. Instead of just string, maybe we wanted to restrict it to alphanumeric characters. So how might you go about designing a data type like that? That's a pretty advanced one. So for people that are still new to this, I wouldn't tackle that. But for people that are more advanced, just think about how you might limit this to more alphanumeric characters or special characters like this. And then for phone number, string is pretty wide for phone number. So how might you go about managing it just like the address? That's a little bit easier, just like zip code, right? It has 2 dashes instead of 1. So how might you go about coding up a data type that just stores phone numbers in it? So that is it though for this tutorial. Hope to see you back for some other ones in the future. Thank you. Bye.